This is Unit 4, Lesson 3, Video 1. We're going to now look at equations in point-slope form. So we've done slope-intercept, now we're going to do point-slope form. Okay, so this is the form. You have y minus y1 equals m, parentheses, x minus x1. And just like before, m refers to slope. Your y1 and x1 are your coordinates of the point you're given. So to write something in point-slope form, you need a point and a slope. So let's say that our point is x1, y1. Then you plug those numbers in here. Notice that you have minus signs in the formula. So the minus signs are really saying opposite. Okay. So we're going to graph, but let's first write the equations. I think that will be easier, an easier place to start. All right, so you're given a slope and you're given a point. So I want to use this formula. Okay, so now I'm just plugging in. So whenever you write equations of lines, x and y stay x and y. So this stays y, this stays x. What I'm plugging in for is x1, y1, and m. So y minus 7 equals m, so negative 3, parentheses, x minus negative 1. So remember we talked about how it should be opposite. So let me rewrite that. We don't want to keep that minus and negative. Write that as x plus 1 because it was negative 1. Okay, here's the equation. All right, let's do this side. So y minus negative 8, so plus 8, equals m, so 2/5, parentheses, x minus 10. Okay. All right, now I think we can go back and graph. All right, so to graph, I need a starting place and a slope. So the starting place isn't necessarily the y-intercept. It can be any given point, and then you need to know your slope. So I need my x1 and y1. All right, so y minus y1. Okay, so my x1 is 3, and that minus 3, remember, we're doing opposite, so positive 3. And then my y1 would be this spot here, but opposite, so negative 2. Okay? And then my slope is 2, and when I graph, I need my slope as a fraction, so I put it over 1 if it's a whole number. Okay, so I'm going to start at 3, negative 2, and I'm going to use my slope, which is 2 over 1. So I'm going to go up 2, right 1, or I could go down 2 and left 1. Well, it's not letting me make my line here, so sorry about that. But it should go all the way through your graph like before and have arrows at the end. Okay, let's look at this equation. So my starting point, my x1, y1, so the opposite of 5, so negative 5, opposite of negative 3, so positive 3. And my slope is 3/4. So I'm going to start at negative 5, 3. And my slope is 3/4, so I want to go up 3 and right 4. Or I could do the opposite and do down 3 and left 4. See if I can do a line this time. There we go. Okay. Okay, so that's graphing. We wrote equations, and now we're going to write more equations. So again, I want to write it in point-slope form. So y minus y1 equals m parentheses x minus x1. Okay, so you need a point and a slope. What I have are 2 points. So I have an x1 and a y1. And really, I could use either point. It doesn't matter. But what I don't have is a slope. But we know if we have 2 points, we can find the slope using our slope formula. Okay, so if I find my slope first, I'm going to do -5 minus 2 over -1 minus 2. I'm sorry, I should do -5 minus 3 up here. Okay. So -5 minus 3 is -8. -1 minus 2 is -3, and we want to reduce. It does not reduce, but a negative over a negative is a positive. Okay, so there's my slope. Now I have an m, I have a slope, and I have at least 1 point. I actually have 2. So now that I have a slope and a point, I can plug it in. So y minus y1, which is 3, equals m, which I just found was 8/3, and then x minus x1, which is 2. All right, we want to do the same thing on the next problem, so this would be a good time to pause and try it on your own. All right, we need to find the slope first. So I'm going to do 4 minus 4 over -3 minus 0. Okay, 4 minus 4 is 0. -3 minus 0 is -3. And this gives me 0. Okay, well I can still plug that in. So y minus 4 equals 0, parentheses x minus 0. However, I know if my slope is 0, then this whole right side is just 0. And if I got y by itself, I just have y equals 4. This is a horizontal line. So it's one of those special cases. If your slope is 0, you have a horizontal line. If your slope is undefined, so if you had 0 on the bottom, it would be a vertical line. But what I have here in the first box is fine too. Okay, so now we're going to be given 2 points, and we want to write it in slope-intercept form. So slope-intercept form is y equals mx plus b. Well, first of all, if you're given 2 points, you can find the slope. So I'm going to start there. I always like to label my points. So the first thing I can do is find the slope. So -9 minus 2 over -8 minus -4. Okay, -9 minus 2 is -11. -8 minus -4 is -4. So positive 11 over 4. Okay, then once I have that, once I have my slope and a point, I can use point-slope form. So I'm still not at mx plus b. I still don't know my y-intercept yet. So your y-intercept is where the line goes through y, so x has to be 0. So this is the point 0, b. So x has to be 0. None of these x coordinates are 0, so I don't just get to pick a y. I have to find out what it is, and to do that I have to first use point slope form. Okay, so point slope, y minus 2 equals 11 over 4, and then x minus negative 4, so plus 4. Okay, so really what point slope form is a tool to help us put equations in slope-intercept form. So to change it to slope-intercept form, what I want to do is get y by itself. Okay, well, before I can move this 2, I need to get rid of the parentheses over here by distributing. So it's 11 over 4x. 11 over 4 times 4 is 11. And then add 2. You add it with its like term. So y equals 11 over 4x plus 13. And that is slope-intercept form. Y equals mx plus b. Okay, so same thing. I would pause and try this next one on your own, and then check back. Okay, the first thing we want to do is find the slope. So this one we are going to run into a problem because we get 4 over 0. And if you try to do 4 over 0 in your calculator, it's an error. This one is undefined. So it's a special case. It's a vertical line. So vertical lines I can't write in point slope or slope-intercept form. It has a special equation. It goes through the x-axis. Vertical lines are up and down, so they cut the x-axis, so it's x equals. And then I use whatever their common x-coordinate is. Okay. Okay, so you're ready to do Unit 4, Assignment 5.